Greetings, M squared here. Today we are going to solve some exponential equations that do not require logarithms. So we're doing this in Algebra 1. Logarithm solving exponential equation you learn in Algebra 2. Before we get started, I want you to remind you that in your packet for this chapter, we have our little chart here that I'm going to be referring to, because sometimes if we're not sure what base to put it in, we can look for which row those numbers are in, and then we can tell what the base is and what power it's raised to. And also, oops, forgot, these are the steps. So we're going to get we're going to make sure the bases are the same. That's our first step, using our chart. Then the next step is to use our exponent rules if we need to. So if there's more than one base on a side, we're going to use our exponent rules to simplify it. Then we're going to set the exponents on each side equal to each other, and we're going to solve that equation. And I don't know if I'm going to check on this one, but I'll kind of go over how to check. So when you look at this, they're all 5. So that's pretty easy. Step 1 is done, because step 1 is get all the bases the same. Step 2 is to use our rules of exponents to change it so that there's just one base on the left to a power and one base on the right to a power. So we see that on the right, it only has a 3. We're good to go on the right. On the left, we have 2 5s as bases. And they're being multiplied. So we need to use the product rule, which says if I'm multiplying like bases, I add the exponents. So I'm going to say 5 to the negative 3x plus negative 2x. And that simplifies the left side so it has one base raised to one power. I'm going to clean that up in a minute. Equals 5 cubed. And now I'm going to actually add negative 3x and negative 2x. If you have trouble with negatives, make sure you get your calculator out. You don't want to make a mistake on that. So negative 3x and negative 2x combine to be a negative 5x. So here is step 2, all right? So step 1, make sure all the bases are the same. They were 5. Step 2 is simplify using your exponent rules. And step 3 now is to write an equation where you set the exponent on the left equal to the exponent on the right. And why we do that is because if these two are equal, and we know this is 3, then we know this exponent has to be 3, because 5 cubed is equal to 5 cubed. So we know that 5x has to equal 3. Now notice I'm talking about this 5x, not these 5s. I'm talking about this exponent has to be equal to this exponent. So this is always going to be a linear equation because we haven't learned any other kind of equation yet. So we're going to divide both sides by negative 5 to get x alone. So that's our goal, to find out what x is. And we find out that x equals negative 3/5. And that is our answer. Now, although I'm not going to check it, I'm going to explain how to check it. You could take what x equals, that negative 3/5, you could change that to, remember that's the same as 6/10, negative 6/10, or negative 0.6. You could put that up into those x's and then combine them and see if you get the correct answer. You could do that in your calculator just to check to see if you get 5 cubed. All right, moving on to the next one. So we see that in this one, the bases are not the same. So step 1 isn't done for us. So we've got to use our little chart. Now, some of you might know what base, but I'm going to look for 6, which is on my list, and then I'm going to look for 36. So I see 6 column, and I notice that 36 is 6 squared. So now I'm going to change 36 to 6 squared. All righty. So I'm going to say 6 to the 3x, which is on the left, but I'm going to change this side to 6 squared because the first step is to get the bases the same on both sides. Now, I'm going to, I don't have to simplify, so I'm just going to, step 2 is already done, right? There's just one base on each side. So I'm going to set my exponents equal to each other, because if this is an equation, and it says it is, then this exponent has to equal that exponent. So I know that 3x has to equal 2. So I'm going to divide both sides by 3, and I get x equals 2/3. And this one's easy to check, so I'll just show you real quick. If I put right there in for x, if I say x to the 3, and then I put in my x, right there, 2/3, and then I know that the power raised, multiplication, because it says 3 times x, that cancels and I get a 2. Is 6 squared equal to 36? Yes. So that's kind of how we check it. All right, next one. Okay, this one's a little tad bit tricky because it says 10 to some power equals, times 10 to some power equals 1 to some power. Well, 1 is not base 10, and these two are base 10. Whenever you see a 1, remember what you get how you get a 1 with exponents. It's to the 0 power. So I'm actually going to change this to 10 to the 0 power, because my first step is to make sure all the bases are the same. And that sometimes is tricky, but it's kind of easy if you just remember to the 0 power is 1. So anytime you see a 1 and you're trying to get it to be the same base, you just take whatever that base is to the 0 power. So that's step 1. All the bases are the same. Now I'm going to use my exponent rules. This is being multiplied, so I know I add those. So I get 10 to the negative 2x plus 2 equals 10 to the 0. Okay, step 1's done, step 2's done. Now step 3 says set the exponents equal to each other. So I say negative 2x plus 2 equals 0, and then I solve this equation. So I need to always try to get rid of addition and subtraction first. Negative 2x equals negative 2. Then I'm going to divide by negative 2. And those are 1s, so I get x equals 1. All right, just a couple more. Now this is the quotient rule. I can tell because things are dividing. Step 1 is already done for us, right? 3, 3, and 3. The next step is to use our exponent rules to simplify, and since it's being divided, I know I'm going to subtract. So I'm going to say 3 to the 5 minus a negative n. I did that on purpose because I want you to see that minus a negative. Sometimes people forget and they just put a minus sign and ignore the negative. So we know that a minus a negative gets us a plus. Okay, so we simplified. Step 2, now step 3, which says the exponents are equal. So 5 plus n equals negative 3n. Now I need to get n all by itself, so I have to first of all get them all on the same side. So I'm going to move these n's over here because I only have a number on one side and it's less steps. Because if you subtract 5, then you have to add 3n. It's 2 steps, but I can just subtract n, and that's 1 step. And then finally, to get n alone, I'm going to divide by that coefficient, and I get n equals negative 4/5. I'm sorry. That would not be negative 4/5. That would be negative 5/4. Alrighty. Maybe you caught that before I did. Alrighty, here we go. Last one on this video. Step 1 is done. Step 2 is done. So really, this is kind of an easy one. We're just going to set those equal to each other. 2m equals negative 3m minus 3. There's m's on both sides, but numbers on only one side, so I'm going to move the m's to the same side that's not the number side, m. So I get negative 3 equals 5m. And so to get m alone, I divide by the coefficient, and I get m equals negative 3/5. All right, I'm going to make another video, and they're going to be a little bit harder, and you can watch that too if you want, but good luck with that. M squared, signing out.